Okay, and similarly, we know that the sign of negative pi over 2 is negative 1. The sign of negative pi is 0. The sign of negative 3 pi over 2 is 1. And the sign of 2 pi is 0. Here's the picture of sine, and this is one of those ones that you really got to know. And what did we were looking for something. We were thinking to ourselves, how come this 1 and this part was just sine theta equals negative 1. So the first place on the unit circle, and so here's what's happening. Here's our unit circle. Here is 3 pi over 2. We're going this way. Notice we start at 0, so if we took the unit circle and we unwrapped it, we're going this way. The first one of these, sine gets negative 1, is right here. And the question is, but now when we wanted sine to equal negative 1/2, we found that, so it happened about somewhere right here and somewhere right here. Actually, I'll put our first ones were 11 pi, 11 pi over 6 and 7 pi over 6. Okay, so, and these are both, we're looking for negative 1/2, right? And so what did we have, why is there two distinct branches of this? And this is why, in a kind of a nutshell. There's only one, this is 1 or negative 1, actually negative 1 is what we're looking for. For every 2 pi, here's a 2 pi interval. For every one of these, there is only one negative 1, or for that matter, one positive 1. And if we just keep taking copies of this and putting it over and over and over, there's only going to be one negative 1 or one positive 1 for every 2 pi radians we go through. However, look at any of these other numbers that are between pi and 2 pi. We were looking for, what, negative 1/2? I'm just going to guess. Okay, so suppose this is negative 1/2. This is negative 1/2. I have these right here. This is going to happen on the way going down, and it's going to happen on the way going up. You'll notice that these are not spaced any particular. This is, the space between here is 11 pi 6 minus 7 pi 6, which on a good day is 5 pi over 6. So this is why this is not dangerous, but this is why you have to understand how to build these circles, the relationship between how these functions look. Why does this have two distinct branches, two distinct infinite branches of different solutions? And why does this have one? Those are really important questions. And those of you who are going to go into real science, where you're going to be using mathematics and trigonometry, and this is especially true of you who are going to become physicists, this kind of analysis is absolutely crucial. It's not important enough to just be able to puke out the answers. You have to understand why they exist. So I suppose we better do a little more of this. And incidentally, those of you who are not going to be scientists or engineers and are just going to be dentists are being forced to take this because the people who are writing curriculum are a little weird. Sorry, forget everything I just said. Or not, you can remember. Okay, let's try something else. How about let's try something a little different. Let's try something screwier. Oh, okay, cosine squared x minus sine squared x plus sine x equals 0. Cosine squared x plus sine squared x. I think that was supposed to be minus. Let me see what it is again. Yes. Plus sine x equals 0. Okay, so once again, if there are solutions, we have a problem here. We have sines and cosines, and that's going to be problematic. But we already know that sine squared x plus cosine squared x is equal to 1. So cosine squared x, this is equal to 1 minus sine squared x. So 1 minus sine squared x minus sine squared x plus sine x is equal to 0. That means I'm going to flip some stuff around. So this is minus 2 sine squared x plus sine x plus 1 is equal to 0. I just hate having negative numbers in front of the squared thing, so I'm just going to multiply everything by negative 1. Multiplying 0 by negative 1 changes nothing. This is 2 sine squared x minus sine x minus 1 equals 0. Hopefully, this will backwards factor. You'll notice this has the form a squared, or a times x squared plus minus, sorry. This has this form, ax squared plus bx plus c equals 0, where x is equal to sine of x. Here a is equal to 2, b is negative 1, c is negative 1. Hopefully this backwards factors easily as 2 sine x plus or minus something. You got minus here and minus here, so one of them's got to be plus, one of them's got to be minus. Minus 1 only has two factors, 1 and minus 1. This, so this is sine x minus 1 plus 1. Plus sine x minus 2 sine x is negative sine x. Plus 1 minus 1 is negative 1. 2 sine x squared, this equals 0. And once again, we're at the races. So we have 2 sine x plus 1 equals 0, or sine x is equal to, oops, sorry, I'm jumping in my head, minus 1 equals 0. I'm going to have to erase this, some of this stuff. We already did this problem practically. We already know what the solutions are from the last one. Actually, the real difference in this problem was just to know to get rid of the cosine by changing it into something in terms of sine. So this one I'm not going to spend a huge amount of time on. And all you got to do is back it up a few feet. Look at what we got here. We got, this translates to sine x is equal to negative 1/2. I believe we just figured out that pi, or 11 pi over 6 plus 2k pi, and 7 pi over 6 plus 2k pi were the solutions. Now I'm old and I have mad cow. If producer, were these the solutions to the last problem? Do you remember? Oh, he doesn't know. If it's not, whatever, go back. We did the solution. We already did this one. I don't want to do it again. Here we have sine x is equal to 1. We know that sine of pi over 2 is equal to 1. So just like in the case of negative 1, I claim the solution to this. Here's two distinct branches, right? These go off into infinity, and these are two distinct branches, right? The solutions to this are pi over 2 plus 2k pi. Incidentally, k here is an integer. And the reason is the same. That can be seen like 4 minutes ago in this lecture. So we're going to be doing more of these. And I guess I probably have time to get this problem up on the board, and then we'll have to change out again. Let me see if I can find something that's even more screwed up. That would be better. It will help you. Oh, this one's screwed up. That's really... 4 sine squared x over 2. 4 sine squared x over 2 is equal to... Oh, plus cosine squared equals 2. Plus cosine squared x is equal to 2. Okay, so we're going to have to reload here. You're looking at a test question or something very similar to it. I guarantee you right away we're going to have to screw around with half angle formulas and stuff. Back after these commercials.